Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone. This is Dr. Susie again. So we'll be going into a new topic, which is a final topic in a wastewater treatment plant for the advanced treatment processes. Alright, so we are going into membrane separations. And for the membrane, as you all know, what is membrane? Alright, is it just a sheet of paper, or it's some kind like a material with holes, or a very solid material? Okay, so the membrane is actually the physical barrier. But remember, the physical barrier not necessarily a solid, because we also have liquid membrane. So it's a physical barrier that gives, or at least helps, the separations of component in a mixture. So membrane basically a discrete or thin interface that moderates the separation or the permeations of chemical species in contact with it. Alright, the membrane itself can be molecular homogeneous. Alright, the pores are homogeneous, or chemically or physically heterogeneous. It can be separations, it can be combinations. Alright, so what is the difference between membrane and filter? Because the definitions seems to be the same, but through convention it is almost like the same, separating. But in terms of filter, normally it's limited to structure that separate particulates larger than 1 to 10 microns above. Alright, however, membrane can separate much smaller particulates and even up to ions, okay, monovalent ions. Okay, these are the comparison that I have requested you as an assignment in a previous lecture. Okay, I've checked the e-learning. Some of you have already submitted, but some of you missed that, so I'm not sure either you've gone through my previous talk or not. But please check it back, and I am not going to highlight on this because you have done this the comparison in your assignment. Okay, let us see a different driving force that give the membrane's capacity to work. Okay, how the membrane works. It comes from different driving force. Okay, one of it is pressure driven, alright, concentration driven. We have electric potential gradient and also temperature gradient. Alright, 4 types of driving force makes your membrane works. Alright, for the pressure driven, normally in microfiltration, ultrafiltration, nanofiltration, reverse osmosis, all these 4 is working well for the separations of water. In wastewater, it's highly being used. Gas separation and pervaporations works in gas, okay, but still require pressure. Concentration driven is example on the dialysis or osmosis. For example, what is osmosis? Okay, osmosis is a net movement of water across a selectively membrane. Okay, membrane is selective in terms of separating. Once you said separate, it has a mixture of it in the liquid and it starts separating, and that part we highlight that membrane is selective, choosing only certain, okay, based on the pore size, based on the size or whatnot. So in this sense, the pressure, the driving force is actually the concentration. Alright, they have a gradient between 2 sides of the membrane. So the membrane itself allowing unrestricted passage of water, but not solid molecule or ions passing through the membranes. Okay, you have salt water one side and another distilled water on another side. You have membrane in the middle, so the water from the distilled water will pass through your membrane, okay, entering your salt side, because the concentration gradient of distilled water is much higher, the water content into compared to your salt water. Alright, okay, that is on concentration driven. Electric potential gradient, we have electrodialysis, membrane electrolysis, electrophoresis. Okay, let us see one, which is electrodialysis, for example. Alright, how the membrane works in electrodialysis. Alright, it requires or it utilizes an electric potential difference as a driving force for moving salt ion in the solution. Okay, again, we have seawater, for example. So the ion, how the membrane works is actually selectively only permits the passage of either anion or cation, but not both. Alright, though you have Na plus and Cl minus, for example, in that case, your membrane only select either your anion or cation passing the membrane. So the separation is due to charge rather than the size difference. So it means that even though both having same size, but it can be separated using electric potential gradient membrane. Alright. The next one is on the temperature gradient. Alright, example of membrane is actually using the driving force of temperature gradient is membrane distillation. So how membrane distillation works is basically due to thermally driven separation process in which the separation occur once there is a phase change. Alright, once you have a liquid, you heat it up. From liquid, it has a phase change to vapor. Then the membrane is actually separating the vapor from one side to another. Okay, so this is few different process on a different driving force. Alright, depending on your operations, you may select any of these membranes. Alright, so on this subject, so basically we only cover on the pressure driven microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Let us go one by one. Okay, this is a simple membrane separation processes on how you look on different types of the membrane. Okay, we have microfiltration, ultrafiltration, nanofiltration, reverse osmosis, and what being separated, what is able being separated by them. Okay, for example, the microfiltrations, it's reject suspended solid. All right, after going through all these micromolecules, multivalent ion, monovalent ions, and water passing through MF, you want to remove further, you want to remove the micromolecules, you can use your ultrafiltrations. Then if you want to use multivalent ions and also micromolecules and also suspended solids, you can use directly nanofiltrations. And reverse osmosis, basically it passing through all your waters. Okay, even monovalent ion is rejected. Alright, so it depends on the pore size difference. Pore size for microfiltration is much bigger compared to NF until the RO, and in fact the passing through of your particulates or molecules that passing through the membrane is basically through the sizes, the pore size. Okay, however, for the RO, it's only diffusions. It's not by the pore size passing through, but it's on diffusion. Okay, the mechanism. Okay, this is giving you a little bit more in-depth compared to just now. Okay, because just now is giving you an idea on the different size, then it's passing through one step to another. But here it's a little bit highlighting on what can be rejected by different membrane. Okay, even if you are using microfiltration at home, normally they highlight that they have microfiltration separations is good for removing suspended solids and bacteria. Unfortunately, if virus, multivalent ions still pass through. Okay, multivalent ion is actually also comprises of all the toxic heavy metals still dissolve in your water, right? So microfiltrations functioning only on removing a bigger size of material, for example bacteria and suspended solid. Ultrafiltration getting lesser. Nanofiltrations, part of multivalent ion, can be removed from your feed. And a reverse osmosis, as we see earlier, it only penetrates water, can penetrate but not other materials. Okay, here we'll give you some comparison in terms of sizes of material that can pass through. All right, for example, highlighting at the very end side of your diagram here is actually conventional filtration. It goes around 10 micron to 100 micron diameter, pore diameter. So basically those which is sometimes much smaller, sometimes much higher than that, it can be, you can use conventional filtration to separate that. However, if let's say you are having this staphylococcus bacteria, which is the size of 1 micron, you might need to use microfiltration compared to normal conventional filtration, depth filtration or whatnot you've learned before. All right, and if let's say you have the influenza virus, okay, it's around 1000 Armstrong over there, so you might start using ultrafiltrations to confirm all viruses, all influenza viruses can be removed. All right, hemoglobin 70 Armstrong. Okay, 70 Armstrong is still within the range of ultrafiltrations. So normally in dialysis, okay, you are cleaning the blood and whatnot, they are using ultrafiltrations on that until you are having monovalent ion and A plus over there, which is the size of 3.7 Armstrong, and that's why it cannot it can be rejected. Okay, and the water is 2 Armstrong, the water molecules. All right, so reverse osmosis membranes are so dense that discrete pores may not exist. That's what I mentioned just now. Okay, for NF, MF and UF, basically you are separating your material through pore size, pore diameter, but for the membrane, it's a dense membrane, so the transfer from one fluid to another sides of the membrane is through diffusions. Okay, so this is a spectrum which is giving you a much clearer, all right, much clear identifications, and it has a different scale over there as well. Either you're using micrometers size of material, or you are using angstrom material, or you are using molecular weight if you know that your material to be separated in a molecular weight figures. So basically you can compare and taking this spectrum as your references. Okay, at the end, at the bottom part of it is actually the process separation material membranes that you can be used for removing the common size of material shown here. All right, so particle filtration, if you look from right, okay, at your right side, basically you can remove human hair, granular activated carbon, beach sand and salt, okay, up to a bigger size of yeast cell. Okay, it can be rejected using a normal filtration, particle filtrations. Okay, and the size is around 10 microns to 100 or 1000 microns size. Okay, you need to see what is the compositions in your wastewater and what to be separated, and then only once you know what the material, you need to identify what size they are. So once you identify what size they are, you know which membrane to use. Okay, so you can study further on this membrane filtration spectrum. Okay, because you can clearly identified on metal ions, on virus, which type of membrane to be selected. And in fact, under one membrane, you can see there is a range. Okay, microfiltration, it falls under 0.1 to 1 micron. Okay, the range is a little bit within that range. Okay, so for 1 micron, the entail of the microfiltration at 1 micron is considered a loose size of microfiltration, and 0.1 microns there, it overlapping with the ultra filtration as well. Okay, we call it as a tight microfiltration, but for ultrafiltration we call it as a loose type of ultrafiltration. The pore size is much bigger, which is almost similar like microfiltration. Okay, so this one you can study further later on filtration spectrum. Alright then, so I would like to have an assignment, to give you an assignment. Please list down in a table form the differences and similarity between all membrane types MF, UF, and F, and also RO. Alright, so the similarity and difference is comprises, it's supposed to be in a table form, so you can list down MF, UF, NF, and RO from top to bottom, or from left to right, but then you jot down what is the similarity. For example, their separation size, okay, size of material separated in what range basically, and then what is their working pressure, what is the working conditions, what is the separating materials being to, but put a brief one. Okay, you might not be able to complete this assignment by only having this set of lecture, but my followed lecture will actually assist you. Alright, so the submissions is through e-learning on Tuesday next week. Alright, by then, thank you. Bye.